6, we've got y equals the square root of x, and we'll call that the square root function. And so I'd like you to think of some combos that solve that, things you can plug in for x and what you get for y, and we'll try to see what the graph looks like. Okay, so someone have a combo that works. 4 and 2 works. You plug in 4 for x, y outputs 2. What else? 0, 0. We always like to try to put 0 in. There's some equations you're not allowed to. It causes it to be undefined. But always try the 0 to see where it's at the origin. So plug in a 0 for x. The square root of 0 is 0. So that's real. Okay, what else?
-1.
What I hear? 3 and 9. Let's do 9 and 3. 9 for x gives you 3 for y. Okay, try plugging in -1. When you plug in -1, y equals the square root of -1. We know that's imaginary, so that's going to tell us something about the domain. You cannot plug in -1 because it gives you an imaginary output. So that's not allowed. Neither is -1.5 or -2, or actually just anything negative is going to cause that to be imaginary. So you cannot plug in a negative. Let's do one more. 1 and 1, that's a good one. You plug in 1, you output 1. All right, so let's look at those points. 0, 0, 4, 2, 1, 1. Over 9 and up through is a little patch where my graph shows up. Also, I could have plugged in 2. The square root of 2 is real. It's just irrational real, so you could round it off as a decimal, about 1.4. And then you start to see this curve show up. And now listen, I want you to catch this. I dotted in, or I filled in that curve between those points because there's little points all along that curve that also solve it. Like if I would have plugged in a half, it had a value for y that matches that. The square root of a half, which is real, is about right there. The square root of 3/4 has an answer. The square root, all those little fractional amounts, I'm just want to convince you, even though I don't like to use those in the t-table just because they're not as fun to graph, but I could plug those in for x. So that's the heart of domain, is what could you plug in for x and get a real output. So I could plug in anything positive, fraction, decimal, integer, or I should say positive integers, whole numbers. You can plug in anything 0 or above, basically the positive numbers. Notice for the domain, I have used a bracket around the 0, which means I can use 0. 0 is included in that set. So domain 0 to infinity. All right, the range, the output values for y were also just positive numbers. There was no way to get a negative out of that. We kept putting in positive numbers for x. It's positive on the outside of the radical, keeping it positive. So the range outputs were all positive as well. So same thing. So from 0 on up, visually, the graph is all positive numbers as well there. All right, is it a function? It is. The vertical line test would only hit this curve one time, making it a function. Any type of symmetry. There's 3 types that we study: x-axis, y-axis, and the origin. The x-axis means if we fold it on the x-axis, that it would match up with itself. So since there's nothing down there to match up to, so it won't have that. Y-axis, you fold it along the vertical line, along the y-axis. Folding it over here, there's nothing over there for it to match up with, so no to that. Origin is 180-degree rotation, so rotating it through 2 quadrants would make it over here, and there's nothing there to match up with. Basically, it's just a one-sided, arc, so it doesn't have another half to be symmetric with. So it has no symmetry. All right, any thoughts on the square root function? All right, so whenever you do later put a +1 on that, or a ×3 in front of it, or a negative sign, or something around the square root function, it's still going to maintain this basic look, but just move around on the axis and maybe be pulled out so it's not as sharp a curve or something like that. But it always, square root function, you're going to memorize looks something like that. All right, number 7. Number 7 is the cube root function. So think of some xy coordinates that solves this equation. Eight and 2. 8 for x gives an output of 2 for y. One and 1 is true. 1 for x. Cube root of 1 outputs 1 for y. How about that 0? Can we put in 0? The cube root of 0, and you can verify this always on your calculator. If you put something in that's not real, your calculator throws out an error message or says not real or domain error, something you know that's not right with it. So cube root of 0, you can check that out, is 0. Okay, something else. Good, I want some negatives. We can plug in negatives if it's a cube root. Now remember that last one we talked about, we could not plug in negatives because it was an even root, a square root. But if it's an odd root, you can do the odd root of a negative number. Cube root of -1 is -1. All right, could I plug in the cube root of 2, the cube root of 5.2, all these different numbers? Could I plug in negative 5.6 or negative 2.9? Yes, you can plug in anything that you want for x. Cube rooted, it comes out to be real. So there's no restrictions on the domain. So we'll say negative infinity to positive infinity. Everything goes. Visually, let's see, 8 and 2, that'd be over 8 up to 1, 1, 0, 0, negative 1, 1, and then there will be negative 8, negative 2. It looks something like that. Kind of swirls around the x-axis. So the range was also negative infinity to positive infinity because I can get positive or negative y values output. When you cube root a negative, it's still negative, so you have positive or negative answers. Is it a function? It is. Vertical line only hits this graph one time. And what about symmetry? It does have origin symmetry. You could rotate this around 180 degrees and it would look like the exact same picture. All right, number 8.